Welcome. Today we're going to tackle a concept that can feel kind of tricky, but trust me, it's one of those master keys to unlocking a whole new level of math.
What's the real difference between someone who gets math and someone who struggles? It's not just about grinding through problems. It's about really getting a handle on a few key ideas first.
In learning science, they actually have a name for this: linchpin topics. Think of them like skeleton keys for a subject. Once you have one, boom, all these other doors just fly open. And today, we're going to forge one of those keys, the radical.
Okay, so to really get this, let's start with a puzzle from the real world. A problem that, right now, we can't quite solve, but we will, I promise.
Okay, picture this. You've got to reach a window, and it's 12 feet up. So you run to the hardware store, and they've got 16-foot and 24-foot ladders. Which one do you grab?
Now, to be safe, you know you need to put the bottom of that ladder 5 feet away from the wall for stability.
So what do we got? The wall, the ground, the ladder. It forms a perfect right triangle. And anytime you see a right triangle, your brain should be screaming one thing.
Yep, the Pythagorean theorem. A squared plus b squared equals c squared, where c is our ladder. So we plug in the numbers. 5 squared plus 12 squared. That's 25 plus 144. So c squared, the length of the ladder squared, is 169. But here's the real question. How long is the ladder itself?
So, to get from c squared to just c, what do? We have to do the opposite of squaring a number. We need to find its square root. We have to answer the question you see right here.
And that brings us to the tool we need to solve this. It all starts with understanding this symbol.
Now, officially, this symbol stands for the principal square root. And that's just a fancy way of saying we're only interested in the positive answer, the non-negative one.
Okay, this slide right here tackles a super common mix-up. I mean, it's true, right? 5 times 5 is 25, but so is -5 times -5. So why isn't the answer plus or minus 5? Well, it's because that radical symbol, think of it like a command. It's specifically telling you, give me the positive root. That's it. So by definition, the square root of 25 is just 5, period.
Just like any language, radicals have their own grammar, their own set of rules. And once you know them, you can simplify pretty much any radical expression that gets thrown your way.
First up, we have the product rule. And this one is so useful because it lets you take a big, scary number under the radical and break it down into smaller, friendlier pieces. The trick is to look for perfect squares hiding inside. Okay, look at this. The square root of 300? That looks tough. But wait, we know 300 is just 100 times 3, right? So using the product rule, we can split that into the square root of 100 times the square root of 3. And hey, we know the square root of 100. It's 10, so the whole thing just simplifies down to 10 root 3. How clean is that?
And it works the same way for division. The quotient rule helps us deal with fractions under that radical sign. It lets us take one big radical over a fraction and split it into a fraction with two smaller separate radicals.
So if you see the square root of 5 over 36, just rewrite it. Square root of 5 on top, square root of 36 on the bottom. Now, we can't really do anything with the square root of 5, but the square root of 36, that's just 6. And boom, there's our final answer, root 5 over 6.
Okay, so we've got the basic rules down. Now let's see how these build into some more advanced but really powerful techniques for cleaning up expressions.
All right, think of this next one as just good math manners. It's like mathematical etiquette. The simplest, cleanest form of an answer shouldn't have a radical hanging out in the denominator. And the process of fixing that, it's called rationalizing the denominator.
And this is a perfect before and after. To get that square root of 10 out of the bottom, we do something kind of clever. We multiply the whole fraction by the square root of 10 over the square root of 10. Now, hold on. What is anything over itself? It's just 1, right? So we're not actually changing the value. We're just multiplying by a very fancy version of the number 1 to clean up that denominator.
Okay, this next idea, this is a really powerful piece of mathematical shorthand. Instead of drawing radical symbols all the time, we can use fractional exponents to say the exact same thing. Just remember the rule. The bottom of the fraction is the root, the top is the power. It's just a different way to write the same core idea.
All right, we've learned the definition, the rules, some pro tips. We have forged the key. So let's go back to our ladder puzzle and finally unlock the answer.
We were stuck with c squared equals 169. So what's the principal square root of 169? It's 13. The exact ladder length we need is 13 feet. So when we're back at that hardware store, the 16-foot ladder is the one we're going to buy.
And just like that, look what we did. We didn't just solve one little puzzle, we mastered a linchpin topic. Getting a real handle on radicals is absolutely foundational for so much of what's coming next in algebra, geometry, even calculus.
So, I'll leave you with this final thought. Now that you have this key in your hand, what new mathematical door are you going to unlock next? Thanks for watching.